Hello everyone. Today we are going to see the various possible solutions of one-dimensional heat equation. We know that this is the one-dimensional heat equation. Let us keep U is equal to x into T. We know that U is the temperature distribution over time and space. In this one, x is the function of x only and t is the function of t only. Let us partially differentiate this with respect to t. So here it will be dou u upon dou t. For x there will be no change because x is not the function of t. T is the function of t. So we will get dt upon dt. Now let us partially differentiate this one with respect to x. Here it will be dou u upon dou x. For t there will be no change. X is the function of x. So the differentiation will be dx upon dx. One more time, let us partially differentiate this with respect to x. Here we will get this one. For this one, it will be d square x upon dx square. Let us take this equation. Instead of this, let us apply this. For this one, we can apply this. Let us take x on the other side. It will come in the denominator. Let us take these two terms on the other side. They also will come in the denominator. For both of these two terms, let us keep a common constant k. First, let us take these two. Instead of d upon dt, we can apply d. Let us take these two terms on the other side. So they come in the numerator. Then we can take it on the other side. So it will come as negative. From these two, let us take t outside. Now let us take these two. Let us take x on the other side. It will come in the numerator. For d square upon dx square, let us keep d square. We can take this term on the other side. It will come as negative. From these two terms, we can keep x outside. Using these two equations, we are going to find various possible solutions of one-dimensional heat equation. Let us see the first case in which k will be 0. First, let us take this one. Instead of k, we have to apply 0 so that we will get this. By forming an auxiliary equation, we have to solve this for t. In the auxiliary equation for d, it will be m. So m will be 0. Let us see the formula. If m is equal to a is a single real root, this is the solution. But we are finding the solution for t. So instead of y, we have to apply t. E power ax will be, here a is 0. So 0 into, and x will be t. 0 into t, it will be 0. So we will get e power 0. E power 0 will be 1. So this is the solution for t. Now let us take this equation. Instead of k, we have to apply 0 so that we will get this. We have to solve this equation for x. The auxiliary equation will be m square is equal to 0. For d, we have to apply m. Since it is m square, there will be two solutions. M is equal to 0 and m is equal to 0. If the roots of an auxiliary equations are a repeated root, this is the solution. But we are solving for x. Instead of y, we have to apply x. E power ax will be e power, here a is 0, so 0 into x. So it will be 1. 1 into c2 plus c3x. Because there is already a term c1. So instead of c1 and c2, we can apply as c2 and c3. In this way, we will get this solution. To find u of x comma t, we have to multiply these two so that we will get this. Now let us see the case 2. In this one, k will be positive. For k, we have to apply p square. First, let us take this equation. For k, let us apply p square. For t, we have to solve and we have to make an auxiliary equation. Instead of d, we have to apply m. Finally, for m, we will get this. We know that m is a and is a single real root. This is the solution. So c1 into e power ax. Here a is p square alpha square. So it will be c1 into e power p square alpha square and x will be t. In this way we can find this solution very easily. Now let us take this one. Instead of k, let us apply p square. And this is the auxiliary equation. For m, there will be two roots. If there are two real roots, this is the formula. There is already a term c1. So instead of c1, we can apply c2. And instead of c2, we can apply c3. And here a will be positive p and b will be negative p. To get u of x comma t, we have to multiply these two. Now let us see the third case. In this one, k will be negative. Instead of k, we have to apply minus p square. First, let us take this one. There is already a negative sign. When we apply minus p square for k, negative into negative, it will be positive. This is the auxiliary equation. For m, we will get this. We know that if m is a and is a single real root, this is the formula to find the solution. Instead of a, we have to apply this, and instead of x, it will be t. Now let us take this one. There is a negative sign. When we apply minus p square instead of k, it will be negative into negative, so it will be positive. This is the auxiliary equation. We can write root of minus p square as root of p square into minus 1. Root of minus 1, it will be I. These are the two roots. If the equation has complex roots as plus or minus ai, this is the formula. Here a is p, so instead of a, we need to apply p. Then to find u of x comma t, we have to multiply these two so that we will get this. We have found three equations. Let us check one by one and find the correct solution. We need to find a solution in terms of x and t, but you can see that here a t is missing, only there is x. So using this equation, it is not possible to measure the temperature at a given time. So this equation only applicable for steady conditions. We can rewrite the equation. We can multiply c1 with these two so that we will get this. We can keep c1, c3 as a and c1, c2 as b. Now let us take this equation. This equation is in contradiction with the law of thermodynamics. Suppose we put t is equal to infinitive. Here it will be e power infinitive. E power infinitive will be infinitive. So for u of x comma t, we will get infinitive. According to the law of thermodynamics, when the time t increases, the temperature will not increase. So this is in contradiction with the law of thermodynamics. This solution is not suitable for the problems on heat conduction. We should not take this one. So this is the correct solution. Let us take that and rewrite. We can multiply c1 with these two terms. We can keep c1, c2 as a and c1, c3 as b. Now we are going to end this session. Thank you for watching this video.